In computer programming, the term hooking covers a range of techniques used to alter or augment the behavior of an operating system, of applications, or of other software components by intercepting function calls or messages or events passed between software components. Code that handles such intercepted function calls, events or messages is called a hook. Hooking is used for many purposes, including debugging and extending functionality. Examples might include intercepting keyboard or mouse event messages before they reach an application, or intercepting operating system calls in order to monitor behavior or modify the function of an application or other component. It is also widely used in benchmarking programs, for example frame rate measuring in 3D games, where the output and input is done through hooking. Hooking can also be used by malicious code. For example, rootkits, pieces of software that try to make themselves invisible by faking the output of API calls that would otherwise reveal their existence, often use hooking techniques. A wallhack is another example of malicious behavior that can stem from hooking techniques. It is done by intercepting function calls in a computer game and altering what is shown to the player to allow them to gain an unfair advantage over other players. Methods: typically hooks are inserted while software is already running, but hooking is a tactic that can also be employed prior to the application being started. Both these techniques are described in greater detail below. Physical modification by physically modifying an executable or library before an application is running through techniques of reverse engineering you can also achieve hooking. This is typically used to intercept function calls to either monitor or replace them entirely. For example, by using a disassembler, the entry point of a function within a module can be found. It can then be altered to instead dynamically load some other library module and then have it execute desired methods within that loaded library. If applicable, another related approach by which hooking can be achieved is by altering the import table of an executable. This table can be modified to load any additional library modules as well as changing what external code is invoked when a function is called by the application. An alternate method for achieving function hooking is by intercepting function calls through a wrapper library. When creating a wrapper, you make your own version of a library that an application loads, with all the same functionality of the original library that it will replace. That is, all the functions that are accessible are essentially the same between the original and the replacement. This wrapper library can be designed to call any of the functionality from the original library, or replace it with an entirely new set of logic. Runtime modification operating systems and software may provide the means to easily insert event hooks at runtime. It is available provided that the process inserting the hook is granted enough permission to do so. Microsoft Windows, for example, allows you to insert hooks that can be used to process or modify system events and application events for dialogues, scroll bars, and menus as well as other items. It also allows a hook to insert, remove, process or modify keyboard and mouse events. Linux provides another example where hooks can be used in a similar manner to process network events within the kernel through netfilter. When such functionality is not provided, a special form of hooking employs intercepting the library function calls made by a process. Function hooking is implemented by changing the very first few code instructions of the target function to jump to an injected code. Alternatively, on systems using the shared library concept, the interrupt vector table or the import descriptor table can be modified in memory. Essentially, these tactics employ the same ideas as those of physical modification, but instead altering instructions and structures located in the memory of a process once it is already running. Sample code virtual method table hooking whenever a class defines a virtual function, most compilers add a hidden member variable to the class which points to a virtual method table. This VMT is basically an array of pointers to functions. At runtime, these pointers will be set to point to the right function, because at compile time, it is not yet known if the base function is to be called or a derived one implemented by a class that inherits from the base class. The code below shows an example of a typical VMT hook in Microsoft Windows. C keyboard event hook The following example will hook into keyboard events in Microsoft Windows using the Microsoft.NET Framework. API function hooking interception using JMP instruction equals. The following source code is an example of an API function hooking method which hooks by overwriting the first 6 bytes of a destination function with a JMP instruction to a new function. The code is compiled into a DLL file then loaded into the target process using any method of DLL injection. Using a backup of the original function, one might then restore the first 6 bytes again so the call will not be interrupted. In this example, the Win32 API function message box W is hooked. .NetFilter hook equals. This example shows how to use hook to alter network traffic in the Linux kernel using NetFilter. Internal IAT hooking equals. The following code demonstrates how to hook functions that are imported from another module. This can be used to hook functions in a different process from the calling process. For this, the code must be compiled into a DLL file then loaded into the target process using any method of DLL injection. The advantage of this method is that it is less detectable by antivirus software and/or anti-cheat software. One might make this into an external hook that doesn't make use of any malicious calls. The portable executable header contains the import address table, which can be manipulated as shown in the source below. The source below runs under Microsoft Windows. See also, callback, delegation, terminate and stay resident, user exit, WinAPI override 32. References. External links. General equals, various hooking methods explained for Linux Macintosh. Windows equals, information on import address table function hooking. Information from Microsoft on hooking, information and various techniques regarding x86 hooking. APISP32 is an application used to hook Win32 API. Detours is a general-purpose function hooking library created by Microsoft Research which works in C/C++. WinSP 3 ways to inject code into another process. HookTool SDK provides a comprehensive overview on API hooking and code injection. A commercial product available too. Madco Hook is a commercial x86 and x64 API hooking and DLL injection library for C++ and Delphi. EasyHook is an open-source hooking engine supporting x86 and x64 and Windows in both user and kernel land. Spy Studio Application Trace. Spy Studio is an application tracer which hook calls, displaying the results in a structured way. Ruetop.com API Monitor is a freeware application that can hook and display 10,000 plus Windows APIs and COM interfaces in 32-bit and 64-bit applications and services. Devire API Hook. Devire is a freeware inter-process hook framework that can be used to intercept other processes' API calls and show full parameter information or create API monitors. WinAPI override. WinAPI override is a freeware for non-commercial use. It can hook Win32 API, COM, OLA, ActiveX, .NET in 32-bit and 64-bit processes. It includes monitoring post-analysis tools. Linux equals, 1. A student research project that utilizes hooking. 2. Functionality that allows a piece of software to observe and control the execution of another process. 3. Use of LD preload to hook shared library calls. Emacs equals, Emacs hooks. Hooks are an important mechanism for customization of Emacs. A hook is a Lisp variable which holds a list of functions, to be called on some well-defined occasion. OS X and iOS equals, Cydia Substrate is a framework for jailbroken iOS devices allowing developers to hook into any other framework or application. Harpoon is an OS X library for runtime function hooking. In-depth API hooking equals, x86 API hooking demystified article on various API hooking methods, for the x86 architecture.